All right, we're going to look at two types of division today. Division by a monomial and then division using long division with polynomials. So, divide polynomial by monomial. So poly just meant multiple terms, monomial just one term. Okay. If I had something like this, let's go 3x cubed plus 6x squared minus 9x, and we're going to divide this by 3x. So we got multiple terms up top, single term on the bottom. That's all I mean by poly divided by a monomial. The easiest thing to do is just split it up. So you can visualize it as 3x being under each one, or write it out. Even if you can visualize it, my suggestion would be for your notes to start with, kind of show it divided up. That way when you look back at it, you'll kind of remember, oh yeah, I just put 3x into each one of them. Something like that. Okay? I know some of them are pretty easy to visualize, but having something like that in there gives you a little bit of a reminder of what you did. So let's see on the first one. 3's cancel. Don't worry about that. X goes into x cubed, leaves you x squared. Just going one at a time through them. 3 goes into 6 twice. So plus 2. One of the x's goes away, so plus 2x. 3 goes into 9 3 times, and the x's actually cancel. So I have x squared plus 2x minus 3. Monomial. That makes sense? Sometimes I think the separation is nice when we have more than one variable. So let's go like 4x cubed y plus 12x squared y squared minus 4xy cubed all over 4xy. Again, you can kind of visualize that 4xy going into each one, but sometimes it is nice to see the separation because you've just got more than just a number in one letter. You get that extra letter kind of thrown in there. So 4x cubed y over 4xy, I'm just going to write it separate. 12x squared y squared over 4xy. Like that. And then individually, look at each piece. Look at your number first, then your x's, then your y's. And in the first one, the 4's cancel. Leaves me an x squared, and the y's actually cancel, so don't worry about that guy. And the second one, let's see, 4 goes into 12 3 times, so plus 3. And I'm left with an x and a y. And the last one, 4's cancel, x's cancel, minus y squared. Take a y out of that. Okay. Now sometimes two of the things that looks confusing to us, we'll see it written in a division format. So as far as a different look, let's say something like this. Let's go with 6x squared minus 10x plus 7 divided by negative 2x. A lot of times we'll see it written in a linear division format. This is really the same thing we've got in the first two problems. I just don't have the negative 2x underneath. So you can rewrite it like this, or go straight to looking at the individual pieces. It really doesn't matter. Right? If I went straight to looking at the individual pieces, it looked like this, where I just throw in a negative 2x under each one. The second thing that we notice that kind of confuses us is I look at that back end. Like, well, wait a minute. 2 doesn't go into 7, and there's no x's up top. So it looks a little strange to us. That's okay. There's nothing wrong with that. Okay? I'm going to take one piece at a time. Negative 2 into 6 is negative 3x. So signs change, and we're dividing by a negative. Negative 2 into negative 10 is a positive 5. Then the x's cancel. And then this is still correct, but usually we'll bring the negative out, minus 7 over 2x. And that's about all we can do. Right? A lot of times with division, what we end up thinking is, something has to go into it evenly. No, it doesn't. We can divide anything. Right? Just think back to your numbers. You can, a lot of times we'll ask, hey, can you divide 20 by 4? Yeah. Well, can you divide 20 by 3? No, yeah, you can. You just get a remainder. Or decimal doesn't go in evenly. I can still divide it. So I can still write this as division. I just can't simplify it anymore because it doesn't simplify. Right? So we're going to see two things that sometimes get us. We'll see linear form. I'm paying attention that that's still a monomial right there. So it's really kind of back to what we're seeing here. Okay. The other thing would be, hey, sometimes it doesn't go into it evenly. So what? I can still write it as that division. I just can't simplify it. Now, when we have a polynomial divided by a polynomial, so if I say a poly divided by poly by poly, what we're going to have to do is use long division. And we're going to use some long division. So we're going to talk about long division here with polynomials. Long division is that old skill from elementary school, doing the long division. Okay? And it follows the same process. It looks a lot worse because we're going to have x's thrown in there. So let's first review the long division process. I'm just make up a number here. Okay? Let's go 5, 1, and let's go 8. We'll do something like that. And let's go divided by 3. A pretty basic division problem from a long time ago. Most of the time by now we use calculators, stuff like this. We need to understand the process. So here's what you did. You looked at that 3 and you thought, all right, how many times does 3 go into 5? Or in other words, what do I multiply 3 by to get 5? And nothing, because 3 doesn't go in there evenly. So we think, how many times does it go in there? 1 time. Then we multiply. 1 times 3, 3. Is this looking pretty familiar? Then you subtracted. 5 minus 3 is 2. You brought down the next term 5, and then you started the process over again. Okay? So we figured it out. We multiplied, we subtracted, brought down, started over again. All right, so let's go through the next step. How many times does 3 go into 25? 8 times. So now, we didn't do 18 times 3, we just took that second one. So 8 times 3 is 24. Subtracts 1. Bring down. Repeat. 3 goes into 11 3 times. 3 times 3 is 9. Subtracts 2. Bring down 8. Repeat. 3 goes in there 9 times. So 3 times 9 is 27. Subtract 1. Stop. And 3 doesn't go into 1. Okay? So this is where we had some things come up back then that you did. All right? You wrote things like, hey, here's my answer, 1839, remainder 1. Okay? We also did 1839 and 1/3 remainder over divisor. And you should also remember at some point you did 1839 and then went like 0.3 repeating because you put the decimal and kept going to see if you can get it to terminate. The key here is I know this is a pretty elementary process, but it's just understanding what you actually did. So we made a decision, best possible decision, multiplied, subtracted, brought down. Repeat it every time. The answers. Depends on what you were working with. So when you first did division, you started with this guy. Then when you were introduced to decimals, you kept going and did this. You did more fractions, you left it like that. Okay. Our focus is going to be this guy because we're going to work with polynomials. And polynomials have letters. I can't very well do a decimal with an x. Kind of stuck there, but I can do a fraction. Okay. So we're going to kind of work that fraction. So just a reminder, the fraction was created remainder over divisor. Whatever this is over whatever you were dividing by. Now let's look at this in a polynomial format. So let's go with 6x squared plus 13x plus 8 divided by 2x plus 1. So I have a poly divided by a poly. I'm going to set it up in a long division format. So that 6x squared one's going on the inside. And that 2x plus 1 is going on the outside. Looks a little strange because we've got the variable sitting there. We're going to follow the same process. So what we looked at back here, the 3 and the 5, first with first. That's what we looked at. Same thing. First, first. So I got to think, what do I multiply 2x by to get 6x squared? And that would be 3x. 2 times 3 is 6, x and x is x squared. Then we multiply. Reminder back here, we said 1 times 3 is 3. So here we go. 3x times 2x, 6x squared. Plus 3x, because 3x times 1 is 3x. So I'm distributing the 3x through that 2x plus 1. Our next step, again, think back to what we did numerically. Right here, we subtracted. Over here, we did 5 minus 3, so now we're going to subtract. 6 minus 6 is 0, so nothing there. 13 minus 3, 10x. Bring down that next term, start over. And notice we're following the same process, just looks a little bit different with the letters sitting there. So now what do I multiply 2x by to get 10x? Positive 5. Now I'm distributing the 5. Okay? And a lot of times some of the confusion comes in, well, how come you don't distribute this whole thing? Think back to the number. When we got to that 8, we didn't distribute 18. We just had just 8 times what was here. Just that next one. So 5 times 2x is 10x. 5 times 1 is 5. And then we subtract. 10 minus 10, 0. And then 8 minus 5, 3. There's no more x's. 2x will not go into 3. There's not an x there. That's the remainder. So the way that I'll write my answer would be 3x plus 5 plus 3 over 2x plus 1. Remainder over divisor. Does that look okay to everyone? Notice, it does look worse, but we're following what we did back here. It's the old format. Works the same with letters. Let's get a different one up here. Let's go 6x cubed minus 11x squared plus 11x minus 2. And let's divide that by 2x minus 3. So my first step is going to be set up in a division problem where underneath is going to be the 6x cubed term. And outside is going to be the 2x minus 3. And I'll work my process. So I've got it all set up. My focus is that 2x and that first value, which is 6x cubed. So I'm thinking in my mind, all right, what do I multiply 2x by to get 6x cubed? And that would be 3, because 2 times 3 is 6, and x squared, because x times x squared is x cubed. Then I'm going to actually distribute, subtract, bring down, start over. So if I distribute 6x cubed minus 9x squared, I've distributed. Now I will subtract. 6 minus 6 is 0. Negative 11 minus a negative 9 is negative 2x squared. Subtract. Subtraction is one of those little pitfalls that gets us with these signed numbers. Okay. Over here on this guy, everything is positive. 13 minus 3 is 10. 8 minus 5 is 3. Now I've got some negatives thrown in. I need to remember I'm subtracting. 6 minus 6, 0. Negative 11, I'll write it out here, minus negative 9, that would be negative 2. Remember, it changes the signs. Okay? What you don't want to do for your notes, you don't want to do this. I'm not saying that that's incorrect, but when you look back at this an hour from now, you're going to go, where'd those come from? Imagine 2 weeks from now, and you're getting ready for a test. You're really going to forget where those came from. So for your notes, you want to leave it the way it is, and then if you like to see the sign changes, maybe write it out to the side. I mean, I don't care what you do on your homework or your test, but you want something good to go back and look at so you can see what you actually did. That'll be the important part. So I would say for notes, if it's tough to visualize this, rewrite it over here. Negative 11 plus 9, there's my negative 2. Okay. That will help you out. Bring down, start over. Okay. So we're saying, what do we multiply 2x by to get negative 2x squared? That would be negative x squared, or negative 1x squared. Whether or not you put the 1's fine. No, x. Oh, thank you. Screwed that up. 1x. Yes. Just the x, because I already have the 1x. Now I distribute. Negative 2x squared plus 3x. So negative 2 minus a negative 2, there's 0. 11 minus 3, a little easier on the subtraction here because it's positive, but 11 minus 3 is 8x. Bring down, start over. 2x times 4 will be 8x. Distribute, 8x minus 12. Now we're subtracting again. So I'd have 8 minus 8, 0. And negative 2 minus a negative 12 is a positive 10. Again, a nice helpful reminder would be to, out here to the side if you need it, negative 2, and if you need it in your notes, minus negative 12. That's where I'm getting that negative 2 plus 12 to get 10. And again, this can be very helpful in your notes. What I see most of the time is on the long division with polynomials, we subtract wrong. It's the signs that get us. We know how to subtract. We just get mixed up on the signs and the negatives get in the way. That does happen. Let's look at this guy here. Let's go x cubed plus 4x squared minus 8 divided by, now let's go x plus 3. Oh, wait. I'm sorry, I did not write my final answer over here. Let's get our final answer. 3x squared minus x plus 4 plus 10 over 2x minus 3. There's that remainder over divisor. Always want to get our final answer down there. Now this one, I set it up in division format. Cubic term is going to go underneath, but there's a little trick in this one. I need to write it as x cubed plus 4x squared plus 0x minus 8. X plus 3 on the outside. That's 0x. Right? That's where we need a placeholder. I'm going to say need placeholder. I'll just do this for that x term. So our polynomials, remember the descending order of power, we should see every place value taken care of. 3, 2, 1, nothing. 3, 2, I'm missing the x. There's where my placeholders coming in. Okay? You've seen placeholders all the time. Right? If I went back to this original problem we talked about, and I change a couple numbers around, if I took that 0 or that 1 out and put a 0, that 0 is really a placeholder. It's holding the tens place. It's saying there's 0 tens. We don't write numbers like this. We don't just leave a blank. We put a 0 in the place to hold the place value. Okay? So if I'm missing a place value for my x's, I want to put that placeholder in there. And that way when things start subtracting, if you need it, it's lining up. There's the key. Pretty easy to tell if we need one. Just look at the powers. If you count down and you're missing something, there's where that 0 one's going to go. Okay. All right. Division process doesn't change. I multiply x by x squared to get x cubed. So this would give me x cubed plus 3x squared. Subtract. 1 minus 1 is 0. 4 minus 3 is 1x squared. And then bring down. I'm not concerned about the fact that there's a 0 there. That doesn't bother me at all. I'm still just bringing down whatever the next term is, just keeping everything lined up. Right? What do I multiply x by to get x squared? Well, that's just x. So I've got my plus x there. X times x is x squared plus 3x. Then I subtract. 1 minus 1, 0. 0 minus 3, negative 3x. There's where that negative's coming back in. I've got to make sure that I'm subtracting. Pay close attention to that because that's typically where most of the mistakes happen. Okay? We're usually really good at lining things up, but we get working quick and we subtract wrong. Bring down my 8 or negative 8. X times negative 3 would be negative 3x. Now minus 9. And then here comes that subtraction again. Negative 3 minus a negative 3 is 0. Negative 8 minus negative 9 is 1. Again, if it helps, go out to the side, rewrite it. Now to remind you how we got the 1 for that piece. Final answer for this guy, x squared plus x minus 3 plus 1 over x plus 3. So anytime we have a remainder, it's remainder over divisor. Whatever that remainder is, over divisor. If you don't have a remainder, let's say your remainder is 0, it all went in evenly. Well, then your answer is just up here, just like a regular division problem. That's your answer. But if I have a remainder, we're going to write it as a fraction, whatever this remainder was, over whatever you were dividing by. Everybody okay there? All right. That's